This session is not something like to know more about physics or to solve problems in physics. It's about okay, how do we guide our students, how do we mentor our students to see to it that they are able to solve problems. Okay, so this is what it is. So towards it, I have designed a website also. So the website I will share at the end to show about okay how useful it is and how do my students also do it and what are the strategies I adopt so that they are able to do well. Okay, let me share my presentation. In this, we will be looking at what are the shortcuts, tips, and possible pitfalls. Okay, while solving the MCQs. MCQs are like a starry night. Okay, so when we look at the stars in the night, we observe there are many stars over there. Each star will have an unique representation. So as a result of it, we think, okay, so this star will pick it up, we'll solve, take that as a problem, we'll understand more about it. That's what we look at it. But when we go to the next star, that star will not be an identical to that one. So in a similar way, MCQs are also present. Okay, now how do we solve that is a question. Just a minute. Okay. Now how do we solve this problem? So before I start my coaching for the students, there are certain prerequisites that I actually do it. The first one is, for example, I have taken a chapter on the electrostatics, capacitors and the dipoles and all this that we have. So I have taken this one as an example, and this is what I actually do it. The first is I give the required mathematical foundation for them. Though these mathematics are already being learned by them in their earlier in mathematics itself. Okay, but still I always feel that okay, they do not know like how to apply it, so they get confused sometimes. As a result of it, I take sample examples from here and start describing the prerequisites. Like for example, electrostatics, the most important thing that we need here is nothing but vectors. So I describe about vectors, okay, and then I proceed, and then after that I describe about table of reciprocals, squares, table of 1 by n square and so on. So what is the reason for this one? The reason for this is nothing but when you say table of reciprocals, usually we have, for example, calculating potential. It goes as kq divided by r. In an MCQ, what is most important is they need to complete an MCQ in a very shorter interval of time. If they take a very long interval of time, they will not be able to do it. Is my slide being seen? Okay, fine. So as a result of it, so definitely table of reciprocals like 1 to 10 is sufficient, not more than that. Okay, so every time, because in international curriculum we allow them to use calculators, but here in CBSE or ICSE we do not have calculators here. So therefore they need to know about it. So 1 by 1 equal to 1, 1 by 2.5, 1 by 3.33, 1 by 4.25. So this is very important. In our days when I was a student, okay, we used to have the table of reciprocals 1 to 10. We definitely had to by heart this. Okay, we always say rote learning is not good, but somewhere these tables are very essential. Nowadays students are not going to it, so I make it to a point that is very required. And squares and 1 by n square. So this is all is very much required here. So as a result of it, I asked them to by heart this one, get to know about this. Then there are some constants like values of okay, so values of constants like value of k, e by epsilon naught. You know, e by epsilon naught is nothing but you use in your e square divided k e square. Okay, so you have, so in that case it becomes very easy for us. E by epsilon naught is nearly equivalent to e by m is equal to 1.8 into 10 power 11. Nobody in an MCQ will ask you something like values greater than having 3 significant digits or 4 significant digits. It will always be something like 1 significant digit or nearest one. So you can easily guess. And between any two what you call options, there will be a gap in between them. For example, if there are 4 options to determine something like the potential. Okay, one of them could be 1 into 10 power 11. The second one, one of them could be 1.8. Second one could be 1.3. Third one could be something like 2.7. Fourth one could be something like 3.5 and so on. So therefore, I need, if suppose the correct answer is 1.3. Okay, the student, if he is attempting this MCQ by putting the formula, calculating it completely, okay, by substituting every value, it takes 2 minutes for him to calculate this. And he gets an answer as 1.3472. Okay, but finally he has to trickle it down and make it as 1.3. So why does it take 2 minutes? Because he is substituting everything, he is dividing, multiplying all this. So why don't, because we already know, we need it only for something like 2 minutes. So easily 1 minute we need to solve it. So see to it that initially when he takes the values itself, he truncates all the values to 2 decimal places instead of having multiple decimal places. So we can use something like shortcuts over here to do this one here. Then pi square, for example, pi square is equal to g, which is equal to 9.8. One more shortcuts over here. Then you have 1uc square. This is something which many of us we often keep on using, okay, in your atomic physics. Hc value, okay, this is something like when we were studying MSc, okay, so we had these kinds of constants which have been taught to us, okay, so Hc, so instead of substituting 6.633 multiplying all this, so you have something like this, and when you say you want to find out the wavelength, Hc divided by delta E is nothing but wavelength, okay, easily you can substitute in terms of this and cancel the units. So most of the time we need to teach, I teach the students using the units, okay, they need to know how to apply the units instead of just writing down the numbers. Let them write the units in the numerator, denominator, and then learn how to cancel instead of just solving something, okay. And then electron volt to joule conversion. So all these are some of the examples which I do initially. Ma'am, you had some question? Yeah.
Sir, I tell my children to take the value of pi square to be 10 at times for the like easy calculation.
Exactly.
And yes, various other constant, they help in solving the question much easier way. My request is if this PPT or the video can be shared in the group.
Sure, ma'am.
Later on.
Yeah, I am recording this video also. Okay, so I can share the video and as well as the PPT if you want. Okay, then multiple formulae for one parameter. This is something which I do. So while I was coaching for JEE also, this is something which I used to do it there. Okay, so for example, if I say capacitance, okay, usually in MCQs they will ask you something about find out this particular parameter. I have just taken an example of capacitance here. So what are all the different formulae that one can use, okay, to find out capacitance? I asked this one to be done by the students. I don't tell them. I asked them. Delhi University, I remember long back when I was in my 11th and 12th. Okay, I'm not from Delhi, but I had a few friends, okay, who were from Delhi. They used to say something like they have a notebook called as a Delhi University used to publish something called as a LMR notebook, last minute revision book. Okay, wonderful notebook actually. Now I don't know whether why it is not available. Okay, now there are several things which has come, something like formula booklet and so on. And this last minute revision, one of my teachers used to tell me, don't buy it from DU, but instead you start writing it. So how he used to teach is that one line, one complete formula or one derivation, one full derivation, one line. So while you are going in a bus or an auto, so you just look into it, you completely recall how it was being done. And that should be done on your own way. It should not be copied from someone else. Everyone will have their own way of writing. So they said, okay, you can adopt something like this. In a similar way, so these are some of the formulas. I asked them to do it like this. So they can write anything. They can link one with the other and they can write all this. This is one thing which I do. And then I asked them to do something like special formula. What is a special formula? Special formula is nothing but when we know about force. Force is something which we all know, M into A, M into G, we use this. But there are certain places, okay, in our physics context wherein we use the same letter F, but it will not be called as force. The unit of it will be Newton per meter. Like for example, when we are doing something like force per unit length between two conductors, two current carrying conductors, F by L we use it there. Okay, so I asked them to recognize while we are teaching in the class itself. I tell them, okay, so please make a note of this special formula. It should come in this category. Okay, so they will write it in the notepad or laptop or wherever it is. And when I ask them to submit it, okay, so they will write this in a notebook like this. E by V, okay, energy density for example, or energy per unit volume, half epsilon naught E square. Okay, so these are the places where these are the kind of formula which need special attention. Otherwise, they will think, okay, so I can use anything. I can just use this as a joule. Okay, so these formula will be definitely be asked in your MCQs. So these are very important. Then finally, multiple ways to understand a concept. So usually when we say about a series resistance, we just say add two resistors, you will get the sum of the resistance to be series resistance. But there are some three hidden facts over there. The other two hidden facts are nothing but the current is same. Okay, so whenever they take a series circuit, okay, they can apply this logic either to current is same, or for example, if I have two capacitors in series, I can say the charge flowing through it is same. So this is something comes to them. That means you learn one concept and you apply this concept to multiple parts, multiple contexts. Okay, so that is what it is. A dielectric in a capacitor reduces the electric field. See, this particular concept, I see to it that, just a minute, let me add the rest of them also. Okay, I see to it that, okay, they understand the same concept from various perspectives also. So using the formula they can understand, and using the concept also they can understand. So something like this I have designed on my own way, and I asked them to do something like this. While they do it, okay, they actually learn twice. If I just teach something on the board and ask them, okay, just copy it down. So what they do is they just copy it down, but they don't analyze it. But when I do something like this, they actually analyze it. So that is where, okay, this kind of treatment is very essential. That's what I feel. Okay, now let me move on to the next slide. MCQ types. Broadly, I have classified into 5 different types. One is comparison problems. In my website also you will be able to see lots of comparison problems I have done separately. 2-step problems. Then you have third one is concept or definition, then connected to the math one. Then the fourth one is pure concepts. For the fourth one, you definitely need to know more about the concept in detail. Okay, otherwise they will not be able to attempt. So these questions they can easily attempt. And the last one is the concept dependent problems. And finally, you have an assertion and reasoning type problems. Of course, in our IB curriculum, we do not have this. Only in CBSE, we do have this one here. Okay, just a minute. Okay, let me go to the next slide. Just a minute. Okay, comparison problems. So comparison problems, what are these comparison problems? In any curriculum, especially in IB, I have seen at least something like 5 to 6 problems from various chapters will be comparison problems. Okay, so comparison problems are something like, in this problem if you look at it, okay, this circle shows you 30 volt, this shows you 20 volt, this shows you 10 volt. If I draw one more circle, this could show you something like something other, which is nothing but a problem on equipotentials. Okay, so they might say at a given distance over here, if this potential is equal to 30 volt, at this distance, what could be the potential? Okay, so these are comparison problems. So wherein the same formula you are going to apply it twice. So this is what you got as a comparison problem. The second type of problem, okay, this is 1A. Then the second classification of this problem is something like, see here what happens is, in comparison problem, you are going to find the actual value over here. In the second type of problem, once again comparison problem, but you are going to divide one with the other and you are going to get, okay, a net number which does not have any unit over here. Okay, so therefore, so there is a pattern which has been seen. So let me go back, let me go to this. Okay, as an example, so you have a conducting sphere of charge radius r and charge with a q over here. Okay, and the potential is V, and if suppose if the radius is increased to 2r, then what could be the potential over here? So, and the charges also change, what could be? So what we can do is we can just say V is equal to kq by r, plug in the parameters and compare it with the actual one, and finally I get the answer. So this is one of the easiest type of problems. Most of the time we get at least 2 to 3 problems. Okay, we can identify when there is a formula and you can change something in the formula, then definitely these kinds of problems can be asked. So this is one type of problem. Any curriculum, let it be KSET, let it be JEE, NEET, okay, IP, CBSE, wherever it is, you can see these kinds of problems coming there. Then the second type of problem, these are some of the examples I have put across. Okay, so these are some of the examples. So one can easily do these kinds of problems. It's not difficult. Any type of student would be able to attempt this, provided he understands the logic over here. Okay. The second type of comparison problem is something like this. Okay, now in this problem, what we have is, you have the ratio of two values, and the options here could be something like, just a minute, still people are joining, so I'm just admitting them, that's why. Okay, I need to interrupt in between, right? So options, so in the options, let us say for example the first option is something like u1 by u2, it gives you something like 1 Newton. B is something like 5, C is something like around 21, fourth one D is something like around 10 centimeter, something like this. So what we can understand here is these two will not have an unit, and as a result of it we can negate these two, and amongst these only we would be able to look into it. Okay, so based on the units also, because they might test something like this. So if they are testing based on units, it could be 1 Newton here, value 1 here, and this could be something like 21, and this could also be 1 centimeter over here, something like this somewhere. So by looking at the units, you can say, you can negate those, and finally you can go for the correct ones. You can actually calculate and get the correct ones over here. So this is the other technique that I teach them. So whenever you are getting something like ratio of two parameters, see to it that the answer present in the options should not have any unit, okay, because the units will cancel out. So these are some of the examples which I usually take it from my papers. Now the possible pitfalls here. Okay, where do the students make a mistake? Is that they make a mistake in errors while doing in a fraction. While they do something like 2 by 3. Okay, so 2 by 3 is nothing but 0.67 what they get, but sometimes they may not do this properly. So we have to train them to do proper fractions. Basically MCQs are not difficult. Okay, MCQs are quite easier, but the only problem is we need to see to it that, okay, they do the math behind it much more easier, and we don't have complex math like doing differentiation, doing integration, applying the limits, okay, boundary conditions. We don't have all this, but the thing what we have is, okay, we have simple algebra. So therefore somewhere practice has to be given for this. That's what I do most of the time. Okay, I give to them the problems in such a way that there are the simple algebraic terms more here. Then one more place where I observed students doing mistakes is that while they do something like squaring or power raising. For example, in our syllabus we have this Wien's displacement law, okay, which is nothing but you have sigma t power 4. While they do this, okay, compare between sigma t power t1 to the power of 4 and t2 to the power of 4, okay, which they get this as p1 by p2 over here, so I1 by 2. So in this case what they do is this t1 by t2 they make a mistake over here. So somewhere while raising to the power also they make a mistake. So fractions has to be given emphasis, squaring or raising the power also needs to be given emphasis, because all this they learn very much in their 9th and 10th grade. When they come to 11th and 12th, we don't emphasize more on something on this, okay, and this comes in math in powers and powers and indexes, I think, indices, I think, okay, a power m into a power n and all this, okay. So therefore, so they make a mistake over here. So somewhere we need to look into these things. So these are the possible pitfalls when we do a comparison problem. Otherwise, definitely comparison problems they should be able to do at least 4 to 5 MCQs, full marks they should be able to get it across. Then the second kind of problem is a two-step problem. So in a two-step problem, we do need something like an intermediate step. Okay, for example, in this case, the current I is given, R is given, T is given over here. Okay, so some of them, if they know the complete formula, so they will just apply I square multiplied by R into T, and they will be able to get an answer. But some of them, what they do is they find out, okay, what is the heat produced by using something like power first they find out, and then they find out power into T. While doing this, R, the direct I square R into T, what they do is they forget to convert 1 minute into seconds. Okay, so somewhere, okay, whenever problems have a two-step problems, or whenever there is a conversion, see to it that we have to tell them very clearly that somewhere all the units should be kept in SI units. That's why what I do is when I begin with the problem in these kinds of problems, two-step problems, okay, so when I write this, okay, on top of it I mention the label, and whenever I have something like this, I instantly convert this one to SI unit, and after that I read across, okay, what is to be found out over here. Because most of students, what they do is their interest would only be in finding out what is that I should do further. Okay, they don't even read the full problem. But what we need to do is 70%. That's what when we were teaching for JEE mains, advanced and so on, we usually tell them all the JEE problems are quite easier. But what we need to do is 70% of it goes in understanding the problem, and the rest of 30% comes in solving it. First understand, write down what parameters are given to you, and after that proceed in solving. Put the mathematical formula. Okay, somewhere that is what I do it, okay, from my personal experience. Then, so these are some of the examples. Okay, so for example, 6 microfarad is charged to 12 volt, discharged through a 4 kilo ohm. How long does it take for a voltage to fall to 4 volt? If I have some questions like this, so first what I need to do is I need to find out what is the initial charge, and therefore the second one is, okay, I use something like Q equal to Q naught e to the power of minus d by RC to come back to the actual one. Okay, so this is called as a two-step problem that I usually follow it. Then, so the possible pitfalls here is understanding the appropriate equation. Understanding the appropriate equation and putting it across. So that could be one of the problems. The second level, the difficulty level is a little bit higher over here. Okay. Next, there are some other. So when they do a mistake over here, how do I identify that I have made a mistake? So that is by, this is something like a chart. I make it across and I give it to them. Okay. So I just take them some examples over here. Planet's mass. While they do something like a problem on gravitation, of course, in first year in our syllabus we have gravitation also as a part of the curriculum. That is your second year, first year and second year together they have to write. We don't have separate syllabus over there. So as a result of it, planet's mass will always be greater than 10 power 20 kg. If they are using something like Kepler's law and get the mass of a planet and they get it as something like 100 kg, then definitely it's okay, you cannot get this one. So then definitely something is wrong. So we need to make a chart of those possible values, okay, for each chapter and give it to them. For example, capacitor. Capacitance, usually the capacitance that we deal with will be less than 1 millifarad, okay, and so on. Some of them do get something like, okay, 100 farad, 200 farad and so on. I tell them, so such kinds of higher values of farads are not possible. So somewhere you made a mistake, look into it, okay. And then combination of resistance in series will always be greater than the largest resistance used. Okay, this is something which they use. For example, if there is a problem which gives you something like there are 2 ohm resistors connected, 100 resistance, okay, which are connected in series. Like first one is 2 ohm, second one is 3 ohm, third one is 4 ohm, and so on. Okay, now if 100 resistance are being connected like this, and the highest one is seen to be 102 ohms. Okay, what could be the resistance? What will be the effective resistance? The effective resistance will definitely be larger than the maximum of it. Okay, there could be 4 options. Okay, so there the question would be tested based on, okay, how are you actually approaching the problem, and not, okay, in understanding how are you calculating it. So therefore the options there given would be something like 102 ohm, greater than 102 ohm, less than 102 ohm, 2 ohms, and maybe 100 ohms and so on. So they need to appropriately write it. Okay, so for that they need to understand this one. Combination of resistance in parallel will be less than the least resistance used. A very important part, okay, in many places. Because if I have only 2 resistances, one is 100 ohm, the other one is 2 ohms, and I ask them to find out what is the effective resistance between these two, then what they do is they keep on calculating that. Instead of calculating it, what they can do is they can look at the options, which one is lesser than 2 ohms. Then you just look into it and put that value over there. Then drift velocity cannot be more than a few centimeters per second. Recently I was correcting one paper, I found out the student has got confused with the drift velocity with the velocity of light. Okay, because he thinks that the current moves with the velocity of light, because the moment I switch on the switch, I see that the bulb is on, okay, at any point, so therefore it should be velocity of light. So these kinds of misconceptions can also be been there. In my website I have made something like around 200 such misconceptions as videos. I put it across, one can visit it. Visible regions will span only from 400 to 700 nanometers. Frequency of hearing works like, for example, we had asked to calculate something like wavelength of light in a YDSE experiment, Young's double slit experiment. Okay, and the student has got something like 1 nanometer. Okay, I had very clearly mentioned that blue light, okay, of certain wavelength was being used in a YDSE. Okay, and then what is the wavelength of light using the parameters given? And the fringe width is given, capital D is given, small d is given, everything is given. But unfortunately, I don't know what formula he used or what is the calculation mistake he uses. And finally, he got something like 1 nanometer. So he can immediately check it out. Okay, how can it be 1 nanometer? It cannot be 1 nanometer. Okay, maybe I would have done some mistakes. He can rectify it once again. So this chart of this would be very much useful. Frequency of hearing. Okay, many places use speed of sound is least in air. So this is one of the denser medium. So usually students get confused when we talk about the speed of sound. So they think, okay, so it should be if I use a metal and as well as the air, they think maybe in metal it should be much lesser. Okay, so this is something which one can look into it. Air is a denser medium, and sound and metals are the rarer medium. They get confused with the reflection of light, what we teach in the optics. Acceleration due to gravity is constant. One of the more biggest misconceptions they have is that when I throw a particle upwards, I observe that the gravity is positive and g value is equal to plus 9.8. When the particle starts coming down, the value of g is equal to minus 9.8. They do this mistake while I have seen something like there are two plates. Okay, in projectile motion we see this in first year, and we also see this when you have an electron moving in an external magnetic field and an electric field, and it starts moving upwards. Okay, because there's a positive plate on the top. They consider something like gravity to be presented. So that should be told to them. And then domestic currents cannot exceed 15 amperes. Okay, so sometimes they get something like as large as 3000 amperes. I ask them, 3000 amperes, how do you get that kind of heavy current? So these things. Seconds pendulum. Okay, there are some examples wherein the question will not be given as what is the time period, but they will say there's a second pendulum which has been employed. So what do you mean by second pendulum? So certain phrases like this are very important in physics. So I actually make all this and give it to them. If source moves towards the observer, this is a general formula which I have. Most of the students actually do it because some students make a mistake. Okay, and frequency, this part, frequency of vibration will not change in reflection, refraction, and diffraction. In fact, in our syllabus, we get this question many times. Something like the frequency of light, or frequency of a vibrating object as observed in air is equal to so much. And when the man is inside a swimming pool, what could be the frequency? Okay, definitely the frequency should not change. Frequency will remain a constant. This is something like many of them make a mistake. Around 70% of the students I have seen, this mistake has been done. Okay, so this is something which is very useful to identify where do they go wrong. Okay, next. Right. The next type of MCQs is purely conceptual MCQs, which is the next level, which requires something like clear understanding of the concepts. Let us take up this example for example. Most of them, 90% of my students did not do this problem when I gave it to them. So two beams, one of electrons, one of protons, move parallel to each other in the same direction. So you have an electron beam here, you have a proton beam over here. Proton beam over here. So when they are moving parallel to each other, and then in the same direction, and then what will happen to them? They said, sir, they will definitely attract over here. But what they miss to understand is that when you say there's a beam of electron is nothing but equal to an electric current. So therefore, a conventional electric current is nothing but positive charges moving in this direction, and negative charges movement will be equal to the opposite to that of this. So which means you have two conductors which are placed opposite to each other, and hence they will start repelling each other. So they had to apply that concept, which does not come to them immediately. Okay, so they will think, they attract each other. So these kinds of conceptual mistakes will be there. So to have a clarity on this, their concept should be really hard enough to understand it. Okay, so what I do is when I talk about something like in this case, when I talk about a current carrying conductor, the force between two current carrying conductors, I just ask them if this conductor is being replaced by an electron, or if I have something like 10 electrons moving in a line, do you think the same kind of things will also apply? Can you apply the same formula? Okay, can you think it is very similar to it? So this will help them to answer these kinds of questions in a much more clearer way. Then, so again, this one also. So when a dielectric slab is inserted between the plates of a capacitor while the capacitor is connected to a battery, which quantity remains constant? So these kinds of questions are the conceptual questions that we have. And then, there are other examples. And then finally, concept dependent. Okay, so this one, they need to know about the concept, but knowing alone a concept will not be helpful, but at the same time, they also need to apply the relevant math here. For example, in this case, so for a wire of resistivity rho, length L, area A is given, rho, L and A is given, and but length remains the same. How does the current change if the same potential difference is applied? So if V is applied and if the area of cross section is doubled, that means I have a single wire of some thickness, and if I double the thickness of the wire, then what can happen? So this they cannot directly understand over here, but instead they should be able to understand how does the parameters like A, rho and L affect the resistance. They have to use the formula rho L by A. Somewhere this is very similar to that of your comparison problems, and once they understand what happens to the resistance, and then they will come back to the change in the currents over here. Okay, so this is something which they need to know, that concept and how to use the appropriate math for it. This will be a little bit difficult for the students. Okay, but once when they are able to solve the first 4 types of problems, I think these kinds of problems would be very much easy for them. Most of the problems in IB would be something like category 5 or category 4. We do not have something like list, explain and so on. We have only these kinds of problems coming into. Okay, there are other examples also which are being given like this. Okay, so which they need to understand about it. And one more type of, okay, one type of pitfall that I observe here is that when we say something like 2 quantities x and y are seen to be linearly proportional. The students do not get to understand about what do you mean by linearly proportional, what do you mean by inversely proportional. They always make a mistake over here. Okay, so most of the students do this one here. Okay, so somewhere this should be taught, because they don't learn this one much in mathematics. They always consider if x increases, then y should also increase, and that is what you call as linearly proportional. But the term actually is different. Here you can say there's a trend being seen. When I say when x doubles, for example, if I have a data like 1, 2, 3, 4, and this is 1.2, 2.4, 3.6, 4.8 and so on. Okay, so then I explain them, if x doubles, then y also doubles. If x triples, y also triples. X becomes quadrupled, y also becomes quadrupled and so on. So only then you can say that x is proportional to y. So something like this I put it across. So in other words, okay, somewhere while we teach, I also see to it that, okay, I explain certain things like mathematics especially, which are abstract concepts, put it in terms of numbers. Okay, these numbers may not be physically related. They need not be something like force or displacement or something like this. But first I explain them using numbers, and finally tell them, okay, this is what is linear proportion. The same thing happens even when we talk about can we apply equations of motion for circular motion or SHM. Okay, most of the students say yes, you can easily apply. If I say velocity is constant, I can easily apply. Now the question is, if a particle is moving in a circle, the velocity will never be constant, because the direction of velocity is always changing. Then I ask them, okay, what do you mean by acceleration is constant? Can you give me some values for it? Then they'll say, okay, acceleration. The first answer I get is acceleration equal to 9.8 is the correct answer. Okay. Then I ask them, okay, if suppose instead of writing a is equal to 9.8, if I write 9.8 times t, now what do you think? Will the acceleration be a constant? They say, sir, you just put a value of t over here. Value of t is very small, then it can be considered constant. For 0.1 second, I think it will be constant. Then I asked them, okay, so if you substitute these values, what are the answers you get here? You get A1, A2, A3. So towards it, what we do is, I give them an Excel file and I ask them, okay, so these are the values given here. Find out what are the acceleration for t values or x values. What are the values over there? Okay, tell me what are the values, and do you see, is there a constant value? Okay, so this also I tell them. So as a result of it, they understand whether something is constant, something is linearly proportional, something is inversely proportional. They do problems based on this. So these are some of the possible pitfalls. Okay, basically what I observe is some students find MCQs to be difficult. Reason is because their basic mathematics is not up to that mark. It's not the advanced mathematics. They will be able to do any kind of integration. They can do much more better things. But the problem is they fail to look at, okay, what are the basic mathematics of it. We always think if the basic math is good, then advanced mathematics is good. But basic mathematics refers to these also. So if they are not good in this, then definitely, okay, they may be good in advanced mathematics, but when it comes to interpretation, they will not be able to do it properly. Next, so this is something like the formula relations, the different kinds of formulae which we have. I just took it from somewhere online, and so I usually give, for in our case what happens is in international curriculum we have something like a data booklet given to them. Okay, so all the required formula will be there and they can use it in the examination also. It is not that, okay, so they have to use it only in the class. In the examination, that particular booklet will be given to them and they are supposed to use it. Okay, so these are some of the examples of formulae that we have. So I think these kinds of things would be much more easier. One difficulty if we give this one is that in the exam also they will expect the same thing, but we have to tell them very clearly, you can use it only while you solve the problems. Okay, but in the exam, if they expect it, they will become a handicap, okay, while it comes to exam. Maybe what I thought was, okay, if we are teaching for CBSE, in the initial stages we can give this, but something like 1 month before the examination we can stop giving them this one and say, okay, you need to practice it, you need to by heart the expressions and then proceed with it. Then finally comes the assertion and reasoning. Okay, so assertion and reasoning, there are two statements which is being given here, and as a result of it, we need to find out, okay, whether the assertion is correct, reasoning is correct, whether both of them are wrong, whether one explains the other one, or both the statements are just true, they are independent of each other. So these are the four options which have been given. So for this, what we need to do is what while I was teaching for the coaching institute, we used to teach this one. So I used to tell them, okay, so just look at the statements over here and guess whether the first statement and the second statement is correct or not. Okay, if you feel that these two are correct, then look for whether one explains the other or not. Okay, that's the thing. Now usually when the students read this, I have seen this, many students make a mistake while they explain assertion and reasoning. So what they do is they read the full statement over there and then they think, okay, so maybe one of them is correct, and they mark randomly over there. So they don't understand what is given over here. Okay, first ask them to practice it. This requires a lot of practice, so only then they will be able to do these kinds of problems over here. So there are some examples which I have put it across based on, okay, how do we do it. For example, in this case, in a series combination of two capacitors, voltage across each capacitor is the same. So which is not true, because it depends upon the capacitance of the capacitor. The charge on each capacitor in a series combination is same. That's always right. So as a result of it, once they understand this, then they can say whether the reasoning is based on the assertion what I have put across or not. So that is very important to understand. So they need some time to work out. So each chapter, if we are able to design questions like this, okay, and give it to them and say, okay, so first understand the statements and say, so instead of giving four options, give them only two options. Say that whether A is right, A is true, R is true, A is false, R is false. Four options over there, and they will be able to understand that, and later on you can ask them, justify whether A and R go hand in hand or whether A and R do not go hand in hand. So that would be a better approach, I feel. Right, so these are some of the so in fact I have not made this, I just got it from some site. Okay, and they had mentioned something like this. Of course, everyone has their own way of doing things. Okay, one need not practice it, but I found, okay, this could be an useful one. Of course, we don't have it, but this could be a useful one. So these terms has to be explained. Okay, so terms like always, never, only if, proportional, inversely proportional. So what do they mean? Where can we apply this? If they are able to do this, then definitely, okay, so they will be able to do the assertion reasoning questions properly. And what I suggest is that, okay, if they are able to practice a lot number of past papers using AR questions, there are several books also available. I just looked into it. Okay, so one can easily do most of the questions using AR questions. So finally, I have come to an end to my presentation. So initially we thought, okay, so MCQs looks like stars, but if you join the dots, you will be able to do something like the constellations, understand what are the different constellations, what could be a property of constellation, and so on. So before I proceed with the website, like how I actually train them for doing the websites, doing the MCQs. Okay, so if you have any questions, you can ask me, and later on I'll go for my website.
Sir, very useful tricks that we can tell to our children.
Thank you.
And yes, much more, I suppose, can be added to that. And we look forward to few more identical workshops from you.
Sure, ma'am, no problem. We'll do it.
And yes, we would like to have a view of your that
Website.
website.
Okay.
Yes.
Now, how I actually, now earlier I used to follow these principles and ask them to work on this. Okay, but sometimes it used to work. Many times it used to fail. Okay, something like 10 and 90%. Okay, though we say everything in theory, but when we start training them, it is a bit difficult. So now I am starting with something new also, or maybe you can look into this website. Is my wait, I have not shared my website. Just a moment. Is my website seen, shared?
No, sir, not visible.
Okay, just a minute. Can you see my website now?
Yes, sir, it's
Okay,
visible now.
fine. So this is my website. So the way how I train my students is something like this. The first one is about misconceptions in physics. So here, this, if you click on this tab, so you will have a set of videos which are being shown over here. So you can see these videos. So what do these videos tells you? So the format of these videos are something like this. I just take up one physics problem, okay, an MCQ generally, MCQ or a structured problem, usually MCQ, and then I present the problem and I show what is the response given by the student, okay, and then I say why that response is incorrect, okay, and then I actually do the working of this one. So this is what I do. So one can look into it. In fact, recently, some 2 months back, I was at Bombay in attending one of the workshops for the Olympiad examinations. Okay, so they had given something like PERs. They said something like PERs, wherein the international community is actually working on these misconceptions in physics. They're looking at, okay, how misconceptions can be addressed. Usually we teach in our schools, okay, what is a concept, how to address a concept. But when we look at a misconception, okay, we need to know more about it. So this is where misconceptions comes into play. Okay, now let me go on to the next one. So these are all past papers. Anyway, this is for, one can use this one here. Now let me show you what is important for us from a CBSE point of view. Okay, now what I'll do is let me click on this concept wise question. I'll share my screen once again. So just a moment, someone wants to join. Okay. Okay, so is my tab visible concept wise? So mastering IBDP physics. Okay, it's visible, I think, yeah. Okay, so this is what it is. So if you look into this, this is how, okay, just a minute. If you look into, maybe I can share this URL directly, so you can open in your tab itself. In the chat box, I'll put this URL because it's taken a long time for me to open this and show it over here. Okay, and it's still opening. Anyway, so in IBDP, what we have is we have our entire physics to be shared into, or we have 5 different units. So the units are, so still the website is opening, so you're not able to see it clearly. I have put the URL on the chat box. You can look into it, or you can just type in as ibphysicswithrao.com and you can go to this website, ibphysicswithrao.com. Now, as you see here, so these are the 5 units that I have: space, time and motion, unit A. Then particulate nature of B, matter is B. So in first part you have only kinematics, forces, work energy, power, rigid body dynamics, Galilean and special relativity. Okay, anyway, this is only for the first year part of it. We don't have it for your CBSE second year. And thermal energy transfers and thermodynamics, we don't have it here. Greenhouse effect, okay, greenhouse effect is also known as gas laws, thermodynamics. All this comes in first year. Only current and circuits will be there, okay, in unit B. Wave behavior, do we have wave behavior? No, right? In 12th standard, do we have wave behavior? I don't think so.
We have oscillations and waves in grade 11.
At 11 we have,
In
okay.
CBSE,
Yeah, and 12th we don't have this one here. Okay, and then fields. So this becomes this, and this unit is in 12th, right? So gravitation you don't have, Okay, so here in gravitational field, we also have electric fields. We just teach fields as a common chapter. Okay, so we just compare and contrast between what is the difference and similarities between these two fields. Okay, so we have electric fields also here. Electric field, magnetic field, we have all this over here. And then the motion in EM fields, induction, electromagnetic induction, structure of the atoms, quantum physics, part of it. No, you have full quantum physics similar to CBSE. Radioactive decay, fission, fusion and stars, we don't have it. Okay, so these two units will definitely be useful apart from plus this one. So you can look into the units like D, E and B5. These are the units that you can look into, which are common between CBSE and our IB students, IB curriculum. Now towards it, let me go for the unit D to show us an example. I'll click on unit D. So this is our unit D here. So for example, I have electric and magnetic fields. I have categorized them. I have taken every problem, solved this problem, and then I have categorized them belonging to a given concept. Okay, so what I actually do is, when I first teach the concept in the classroom, and then I tell to my students, okay, these are the problems given to you. You can look into these problems. Okay, first read the problem, understand the problem. If you do not get the answer, then look into the video. Otherwise, you pause the video and then do it. For example, let me go for these equipotential surfaces. Okay, so I clicked on equipotential surface. It takes me to an YouTube link, YouTube video. So there are totally around 1,600 MCQs which has been solved as of date from CBSE. So not from CBSE, from from IGCSE, that is AS Cambridge level, and as well as the other one, that is your IB level. Okay, so totally so many MCQs has been solved. Okay, full solutions have been available. Okay, they can look into it. So and then if they learn these 4 or 5 MCQs, definitely, okay, they will be able to understand the concept also, because we teach a concept, okay, and then we teach multiple concepts, and then what we do is we go to the end of the chapter and teach them the problems. Okay, but instead of it, here what we do is after every concept, okay, whichever problem belongs to that concept, I have put it across, which is not there in the textbook. So this is what I have arrived at. So okay, so now are you able to see my screen? No, it's not seen. Okay, just let me share the screen. Right, so this is how it looks like. So when I clicked on one of these links, okay, so you get a video like this. They can look into this video.
For the field and 4 possible paths are given.
Okay, now what I do is here is that I put a timer also here. See to it that, okay, each problem is we are able to solve it in 1 minute. So I have employed all the shortcuts that I have mentioned over here, and I use this one here. So this is how MCQs have been solved over here. This is one thing. And the other one, usually, students are students. Okay, how many ever times we train them so they don't get accustomed to it. So I do also have something like every day I published 5 problems from the very beginning, from the year 1 itself. I've been doing this. 5 MCQs have been given. 5 MCQs in the morning, I give it as a worksheet to the students, and in the evening, by evening, I want them to solve all of them. Okay, and in the evening, if they are not able to solve it, okay, they just need to go to the YouTube and find out that these problems will be published in the evening at 4 o'clock, so they can look into it. This is one thing that I do. But we will always question, okay, how useful it is, okay, only solving something like this. In addition to it, I also have something like one problem per day. Okay, let me share you this. Okay, so this I do not know how much will it be useful for the CBSE, but definitely for understanding the concepts, it will be really useful. Okay, so here, as you see here, I have something like a homework portal. Okay, so if you click on this one here, so this is your homework portal. So it goes like this. Okay, so now there are several homeworks which I had already given to them. Okay, so like this, for example, so for 30th September to 4th October, for example, I had given them, okay, problems on momentum, forces and projectile motion. This is for the first year, this is for the second year, and so on. Okay, so they just need to look into it. Okay, so one problem only they are going to solve it. So like this also we can actually train our students, because doing one problem per day starting from the first year or starting from second year will not be very difficult for them. So one derivation per day, along with that 5 MCQs. If I give so much, I think that's more than sufficient. They'll be able to really complete all the syllabus complete, because each problem max to max I'll be explaining this only for around 10 to 15 minutes. Okay, and that again depends on how many marks it is. Let us say if it's for 5 marks, I do it only for 5 marks. So it's something which I follow. So as a result of it, students are able to get better marks. So with this, I think I can end my session. I think that's it. Thank you. So visit my
Thank you,
website.
sir.
Yeah.
Thank you very much. And it is actually a privilege listening to you and your wonderful website. Any other member would like to come in, please? Welcome. You are welcome. I think Gurmeet sir is saying something.
Yeah.
We have a very respected Pragya ma'am with us. Pragya ma'am, would you like to say something? Sir, do you take any online classes?
Yes, ma'am. I do take online classes only for IBTP students, and as well as for the for IBTP students and some students from foreign universities, like for degree students also I take.
Okay,
BSc.
one of the member is asking this question. Sir, do you take any online class for the CBSE revision board exam?
No, ma'am. This year
2025.
it's already filled. Okay, I don't have much time.
Okay,
Maybe next year I
Right.
can think about it.
okay. Any other question? Members, if they have any net issue, they can put their question in the chat box.
Yes, I'll enable the chat box.
I think that's it, sir. Thank you so much.
Thank you, ma'am.
Thank you, sir. Thank you so much for this wonderful contribution to the group member for the group members.
Thank you, ma'am. Hope it was useful for everyone. Yeah.
Yeah, yes, sir. Thank you, sir.